Okay, grade 10s, I'm just going to quickly work through an example so you guys can see what the process is of solving electrical circuit questions, especially these more difficult questions, because you can definitely expect questions such as these in your tests and your exams. Okay, so let's take a look here. What is the total resistance of the circuit when switch S is open? When switch S is open, why is switch S? It's over here. And what does that mean? That means that the current won't flow through this branch of my parallel split here. So in fact we have a series circuit then. So the current will flow through the 10 ohm and then through the upper 5 ohm and straight through. Okay, so we have what we call a series circuit there. And they ask what's the total resistance? Well, in series we can say that the R total is equal to R1 plus R2, we just add them together, and in this case the first resistor is 10, the second resistor is 5, so my total resistance is 15 ohm. Okay, so if it's to be marked, you get a mark for the formula and a mark for the answer, not always for substitution, but it can be depending on what the situation is. Okay, so now we know that the total resistance is equal to 15 ohm. That's important for the next question, where they ask us what is calculate the current in the circuit with S open. So we know that R total is equal to 15 ohm. We can use Ohm's law. I is equal to V over R, okay, to calculate the current. So what is the potential difference? They give it to us, it's 45 volts. So I'll substitute that in. It's 45. What's the total resistance? It's 15. 45 over 15 is 3. And my units are amperes, so 3A. Okay, quick and simple. Formula, answer. Once again. So now we know that the current that's flowing through this circuit is 3 amps. And there's the path of the current. It's not flowing there at all because the switch is open. Okay. Next one, calculate the potential difference across the 10 ohm resistor if S is open. So in the same scenario where we have the 3 amp current flowing through all of our resistors here, they're asking what is the potential difference. So if I took a voltmeter, connected it over the 10 ohm, what reading would I get? Okay, remember voltmeter measures the energy before and after the current passes through a resistor, and our electrons use energy to pass through a resistor, and that's why it calculates the difference in the potential energy. So that's why it's called potential difference. So to calculate it, we can just say V is equal to current times resistance, just another variation of Ohm's law. What is the current flowing through it? It's 3 amps, right? I'm just going to remove this here so we have space. And what is the resistance? Well, it's a 10 ohm resistance. You don't have to write the units in there. That's just for clarity. 3 times 10 is 30 volts. Okay. So this voltmeter over here, this one would have a reading of about 30 volts. Okay. That's straightforward. That's the type of questions that you did in grade 9 and grade 8 when it came to circuits. You just need to know what is meant, what they mean by when they say the switch is open. Next, they ask us, calculate the total resistance in the circuit if switch S is closed. So the total resistance when switch S is closed now. So I'm just going to quickly redraw here. I'm just going to say, so here's my 10 ohm. And then I have 5 ohm and 5 ohm. You connect the two. So that's the only resistance in my circuit, and I want to know what's the total resistance. Well, firstly, we're going to have to calculate the parallel resistance. So 1 over Rp is equal to 1 over R1 plus 1 over R2. Okay, so 1 over Rp is equal to 1 over 5 plus 1 over 5, right? And then if we just continue on that line, we can see 1 over Rp is equal to 2 over 5. If we flip that, you can use your calculator, but if you flip that, you'll see that Rp is actually 5 over 2. Alright, which is actually 2,5 ohm, which is less than it was in series, or less than the total resistance was in series. So now they want our total. This is for question 2.4. Yes, 2.4. So for 2.4, our total is equal to my R series plus my R parallel. And then I get 10 plus 2,5, and the answer is 12,5 ohm. 12,5 ohm for R total. Alright, how would the marks be allocated here? Well, pretty much for calculating your parallel resistance, final substituting, and then the final answer. And then for total and your answer. That's a couple of marks as well. Okay, so now in the scenario where the switch is closed, the total resistance is 12,5 ohms. That's important for the next section. So we're going to continue saying if this is closed, and let's just keep what we have. I know that our total is 12,5 ohms, and I know that the potential difference total is 45 volts. Now, calculate the current through the 10 ohm resistor if S is closed. Well, the current there will be the same as the current throughout the whole circuit, the series part. So the current there, here the current will split, but here it will end up joining again, and then it goes back. So they want the current at this section. Well, I is equal to V over R. What's the potential difference for the total circuit? Because that's what I'm going to use here. I'm going to use the total resistance. Alright, so V total is 45, total resistance is 12,5. Okay, the reason that we're using that is because I want to know what the total, the big current is. I'm not concerned yet with the current in the smaller sections. So I'm using this current that is flowing through everything, and that's why I'm using everything's resistance. Okay, so, and that gives me an answer of 3,6 amps. Alright, so what happened when I added a resistor in parallel? My current actually increased because the resistance decreased. Okay, those are the type of questions that they'll ask in multiple choice and in the longer sections as well. You must see what influence it has when you add an extra resistor. Okay, so this is for question 2.5. Your marks will be formula and correct answer. Okay, if you do in circuits, if you made a mistake somewhere previously, so for example in the previous question I made a mistake of calculating parallel, and here it comes ahead and I have a wrong value there, we will mark positively following up. So even if you made a mistake there calculating this, as long as what you did here, everything else is right, you won't lose marks for using the wrong value there. Okay, so just keep working on, and yeah, remember that. Next one, calculate the potential difference across the parallel resistors if S is closed. So now we're asking, if I had a voltmeter across both of these, what would the reading be? Okay, well, we just repeat the same procedure. Okay, so this is 2.6, and they want the potential difference, so I use V equals I times R. Right, what's the current that's flowing through them combined? Well, we know it's 3,6, the total current. And what is their resistance? We calculated it's 2,5, the parallel resistance of both of them together. So 3.6 times 2.5, what do we get? 9 volts. Okay, that is the potential difference used in that section. Yeah. Next, calculate the current through one of the 5 ohm resistors. So I know that the potential difference over here is 9 volts. And in parallel, with this closed, in parallel, we know that this potential difference here, I'll get another color. this potential difference and this potential difference has the same value since they are in parallel. Okay, if I also had another one here over the 5 ohm at the top, it would also be 9 volt. They have the same potential difference. That's a characteristic of my parallel resistors. Okay, so now they're asking me calculate the current. Well, I equals V over R. What is the voltage? It's going to be 9 volts over any of them, since we calculated in the previous question. And the resistance in this branch, what's the resistance there? It's 5 ohm. So 9 over 5, 1,8 amps. Okay, and what do we see? That's actually half of the current that we had. It was 3,6 amps. And since both of these resistors are the exact same size, the current actually halves. But you can actually go calculate it with a formula. Okay. And then lastly, this is 2.7, 2.8. Calculate the potential difference across one of the 5 ohm resistors. Okay, so you see what we have now here. We can go and use the V equals I times R. We can go and use the current. Well, I calculated the current to be 1,8, and the resistance is 5 ohm. So what do we get? 1,8 times 5 is 9 volts. So there you see we just get the same thing. You could have, in the previous step here, you could have just gone ahead and said that the current divided itself in half, and that's why you get 1.8, but I just showed with calculations, and here again with calculations. So you'll get marks. You always get a mark for your formula. You need to write the formula. Even if you don't get a mark for the formula, you lose marks if you don't write the formula. So it's crucial that you write this section down. Either in this form or that form. For circuits, it doesn't really matter, as long as you write it down and then substitute. I hope that makes sense. Please talk to me. We're going to be doing lots and lots and lots of circuits until you're dead and tired of it. I'll be doing a few questions extra as well, but I'm doing one question a video. I hope this helps.